Okay, so we're going to practice a little bit of all of the three versions of solving systems of equations today. So we've got our graphing, we've got our solving by substitution, and we've got our solving by elimination. The graphing is obvious. We have to find our y-intercept, and we have to use our slope from our y-intercept in order to plot points on the line. And then we have to determine where the two lines cross, providing they do. So if we start off with number 1 here, our y-intercept for the first equation is 2, and our y-intercept for the second equation is 8. So I need to put a point at 2, and I need to put a point at 8. And then from there I use the slope. So here my slope is m equals -5 over 6. That means down 5 from my y-intercept to the right 6. Now, which y-intercept? The 2. So I've got to go down 5. 1, 2, 3, 4, 5, and to the right 6. 1, 2, 3, 4, 5, 6. And you're always best to write your slope with the arrows. That just reminds you exactly where you need to go from one point to another. Now I'm going to change the color of the pen so we can draw this line in with red. Now I'm also going to go the opposite way. This says down 5, right 6. I'm going to go up 5, 1, 2, 3, 4, 5, and now to the left 6. And I'm going to put another point there. All three of those points are on that line. And I did that because there's a chance that that point over there is where these two lines are going to meet. Now, from my other y-intercept, and I'll do this one in black, it says to go from the 8, it says to go up 1 and to the right 6. So my slope is +1 over +6. That means up 1, right 6. The alternative to that would be down and to the left, which I can do. So I'm going to go up 1, right 6. That puts me over here. Didn't get closer to the line, the other line, the red one. So I want to do the opposite. I'm going to go down 1 and to the left 6, and you see we land on that same exact point. And that's why I extended that line over there, because I had a feeling that that's where they were going to meet. That is the coordinate that they meet at. So the solution for this set of equations is to the left 6 and up 7. Okay, again, once you're looking for a coordinate, you got to remember you have to go back to the origin, 0, 0. That's where you start your counting. When we're dealing with our y-intercept, we start from that point. But when we're dealing with an actual point, then we start at the origin. So I went left 6 and up 7. That gives me my solution. Okay, I'm going to do one more of these graphing ones, and then you're responsible for the other two. So let's take the last one. You can do 2 and 3 on your own. Again, same idea. I start with my y-intercept. That is at +1. So I put a dot there. I'm going to finish this one line first because I'm doing it all in one color. Then I recognize my slope is 3 over 2. Okay, that means up 3 and to the right 2. So I count up 3. That puts me at 4. Right 2 puts me at this point here. Up 3 again. Right 4. 1, 2, 3. 1, 2, 3, 4. Puts me here. Something didn't go. No, it's not right 4. That's why. See, something didn't go right with my first one. It's right 2. Up 3, right 2. Now I'm going to go the reverse. I'm going back to my y-intercept, and I'm going to go down 3 and to the left 2. So I changed both of those. And the reason that I'm doing that is because of where I start on the other line. I'm also going to do that again. From this point here, I'm going to go down 3 and to the left 2. I have a feeling we might meet over there somewhere. Now, how do I know that? Just look at where we start. The second line, my y-intercept is -6. We're starting clear down here. It's not very likely that we're going to meet some point up here, right? So that's why I assume that we're going to meet at a point down further, all right? So from there, I have a slope that's -1/4. That means down 1, right 4, or up 1 and to the left 4. So if I go down 1 and to the right 4, that puts me here. Didn't get any closer to the line. So instead, I'm going to go up 1 and to the left 4, and ba-bam, we've got a spot where they cross. Okay, and again, that's what we're looking for, is that coordinate. So my solution is, from the origin, I have to go to the left 4. I always go the x direction first, and then I have to drop 5. And that's my solution. Okay, so you have the other two to finish here. Okay, now I'm going to go to the second page. The second page says to choose your method. We get to pick whether we want to do by substitution or by elimination. Okay, so I'm going to make this real simple. I'm going to do the first one by substitution. Now, I do not have one of the two variables by themselves. So I'm going to rewrite this equation right here so that one of the variables is all by itself. All right, actually, I'm going to use elimination. I'm going to use elimination. I look at these numbers and I notice that 2x and -1x differ by a value of 2. So I'm going to take this entire equation and multiply it by 2. Why? Because I get -2x minus 2y equals 28. So the first equation is 2x minus 6y equals 28. And then I can just add them. So I'm going to use elimination because I recognized right away that it would be easy if I use elimination. So now all I do is add straight down. 2 plus -2 is 0. Those zero out. That was my goal. I've got to get rid of one of the two variables. Then I have -6 plus a -2. Remember, we're adding this whole thing. I should write that out in front. We're adding the second equation to the first. Well, if we add two negative numbers together, we get more negative. And then we have 28 plus 28, which is 56. I divide by -8, and I get y is equal to -7. Okay, 56 divided by -8. So now I know what y is equal to, so now I take that and I plug it back in. Now there's not a lot of space here, and that's why I'm not having you do all of these problems. I'm going to have you pick. So first off, I'm going to eliminate this one so I have some space to work. So I'm going to write right in here. Now, it does not make a difference which equation you pick. If you don't like having the negative with nothing in front of it, that happens with the second equation, then don't use that one. But I'm going to use that because I know when there's no number there, it's a 1. So that means that I'm literally taking -1x and I'm multiplying -1 times my y value, because that's what I got. Here was my y value. And negative times negative is positive, so I have -1x equals, stop, back up a little. Forgot to write down what -1 times -7 is. Plus 7 equals 14. And then I subtract 7 from both sides. I get the opposite of 1x equals 7. 14 take away 7 is 7. But because that says the opposite, it says the negative of x is 7, that means x is actually equal to the opposite of 7, or -7. So I end up with a solution of -7, -7. Okay? So I could use elimination for problem number 7. by multiplying this first equation by 2. I would get exactly the same x values. So you do that and finish that problem. Let's drop down to number 10. Number 10, I can easily rewrite this equation so that I have the y all by itself by simply adding 2x to both sides of the first equation. What happens when I add negative 2x and positive 2x? I get 0. So I just have y on that side of the equation. And I add 2x to the opposite side, so I have 2x plus 10. Now I know what y is equal to. Now I can substitute that in for y. Okay, again, pick ones that you can eliminate. I'm going to eliminate this so that I have room to plug this in. So my original equation was negative 6x minus y. It now becomes negative 6x minus the entire thing, 2x plus 10. Okay, now there's a negative 1 in front, so that means that I'm going to multiply each of those terms by negative 1. So I get negative 6x minus 2x minus 10 equals 14. That gives me negative 8x minus 10 equals 14. And you may have to expand even more to be able to fit these in here. Add 10 to both sides because that zeroes out. And I get negative 8x equals 24. Divide by negative 8. And I get x equals negative 3. Okay, I now have the x value, but I don't have the y value. So I'm going to plug that back in for x in one of the two equations. I'm going to choose the first one again. So I have negative 2 times the x value, which is negative 3. Negative 2 times negative 3 is positive 6. And then I subtract 6 from both sides of the equation, and I get y equals 4. Remember, these zero out, and 10 minus 6 is 4. Okay, so my solution, you're going to have to be creative with your space here. Try to do problems that are apart from each other so you have enough room. Again, you're not doing all of these problems. I'm going to have you pick a certain number. So this one I solved by substitution, and I ended up with negative 3, 4. Either process, whatever works best for you. Now, I will say, if you do problems 13 and 14, or 13 and 15, or 14 and 15, you can see that in 14 we have 7x and 7x. So I can simply subtract. Why would I want to do substitution? Okay. Instead, I can subtract and use elimination. But if you look at number 18, we already have y is equal to. So I can substitute that whole thing, 2x minus 20, into, or in place of y. Okay, so you pick. I even have an easier set down here. Y is equal to 1. I already know one of the two values, so I can substitute that into there. All right, so what I want you to do, all the way up through problems number 24, I want you to pick 5 more problems. Pick 5 more problems. It doesn't matter which ones you do. Pick any 5 and solve those for x and y. Okay? So you do not have to do all of these. Pick any 5 of the remaining problems and solve for x and y. Okay? And scratch out ones if they get in your way. Like number 8 is kind of in the way here. I'm going to just scratch that out. Just scratch right over top of them. So you should have 5 more finished. You pick whichever 5 you'd like to do.